Okay, today's aim is are all the converses to the parallelogram theorems true? And the one I want to focus on now is the converse of this theorem, that if a quadrilateral is a parallelogram, then consecutive angles are supplementary. What is the converse of this? The converse of that is going to be, and again I misspelled consecutive, shame on me, if consecutive angles of a quadrilateral are supplementary, then the quadrilateral is a parallelogram. If consecutive angles of a quadrilateral are supplementary, then that quadrilateral is a parallelogram. How do I know that this is true? I mean, I know it's true. It's the theorem that is in your notes, but how do I know? Now, the proof of this is actually quite quick and quite simple. So I'm going to draw a quadrilateral. That's A, B, C, D. And suppose I'm given that angle A plus angle D is equal to 180. Suppose that is given to us. And we'll do a formal two-column proof in a moment. And suppose I also know that angle C plus angle D is equal to 180. Well, how do I know, therefore, that this quadrilateral is a parallelogram? So I'm going to call this angle angle X. I'm going to call this Y. Okay, so if it's true that x plus y is equal to 180, if it's true that angle A plus angle D is equal to 180, what does that mean? Well, here is what I will call a transversal. And here is a side, and here is a side, or a line segment. If I know that I have these two line segments that are cut by this transversal, which I will call T1, and if I know that these same side interior angles, namely x and y, if these same side interior angles are supplementary, because that's what it means, supplementary means their sum is equal to 180, well, what does that mean? What does that mean about these two lines, AB and DC, that are being cut by this transversal T1? It means that these must be parallel to each other. Now, if it's also true that angle X, or angle C plus angle D, angle C plus angle D are equal to 180, right? Well, that would also mean that if that's true, I have this as my transversal, which I will call T2, and now these are my two lines, namely AD and BC, being cut by this transversal. Well, if that's the case, that angle D plus angle C is equal to 180, well, that means I have another same side interior angles, another pair of same side interior angles, namely this one and this one, that are supplementary. Well, if that's true, then what does that tell us about line segments AD and BC? Well, they must be parallel. Well, if I have both pairs of opposite sides that are parallel, what must ABCD be? ABCD has got to be a parallelogram, so that is our proof. So let's take this down. If an angle of a quadrilateral is supplementary to both of its consecutive angles, right? So consecutive angle to A is D. A consecutive angle to A is also B, right? These are consecutive, and these are consecutive. Take this down in your notes if it's not already there. Take down the diagrams as well. They have to be there. Put your player on pause if you need to, and hit play to resume. We're going to do a two-column proof together. Okay, let's get started. So, given A is supplementary to B and A is supplementary to D, prove ABCD is a parallelogram. Let's do a two-column proof. So, here's my statement, here's my reason, and it should go pretty fast. So, statement number one, angle A is supplementary to angle B. Okay, that is given immediately. What do I know because of that? If A is supplementary to B, that means angle A, this is my scratch pad, angle A plus angle B sum to 180 degrees. Well, what does that mean? Immediately, I know that if A and B are supplementary, that means that line segment BC must be parallel to line segment AD. And the reason for that? Same side interior angles are supplementary. You can say the converse of the same side interior angles are supplementary theorem, right? In other words, if two same side interior angles are supplementary, the two lines being cut by the transversal are parallel. Let me see if I can write this more neatly. converse of the same side interior angles are supplementary theorem. What else do I know? Well, they're also telling me that, so I got this, check. Angle A is supplementary to angle D. So angle A is supplementary to angle D. Reason for that? It is given. Well, what do I know because of that? Well, I know that if A is supplementary to D, these two, right? If A is supplementary to D, then there's another pair of same side interior angles that are supplementary. These are supplementary. Let me draw that nicely. There, one arc, two arcs. If that's true, that would mean that AB and CD are parallel. So I can say that line segment AB is parallel to line segment CD for the same reason as I have here. And what I'm going to do, out of sheer laziness, I must confess, I'm going to clone this. I'm going to move it down here. And I'm just going to add what I'm missing here. So the converse of the same side interior angles are supplementary theorem. You can also just say same side interior angles are supplementary. Perfectly fine. Our fifth and final statement has got to be what? Well, look, folks. If I got both pairs of opposite sides are parallel, what must ABCD be? ABCD has to be a parallelogram. So my last statement is going to be ABCD is a parallelogram because both pairs of pairs of opposite sides are parallel. And we are done. Folks, this needs to be in your notes. You need to write this down in your notes. Statement and reason. The given, the prove, the diagram, the statements, the reasons, you need to know these.